Hello students, welcome back. We are done with section 1. Let's go to section 2, numerical description of data. The first topic is mean. And it's an easy concept. Just add up everything and divide by the total number of items. Here's an example. Here's a data set that we had been discussing from section 1. The score distribution of a hypothetical class. Just add up everything and divide by the total number of students, 23, and that's what we get. That's the mean. That's the class average. By the way, there's something called sample mean and population mean. In terms of computation, they're the same. Just add up everything and divide by the total number. Except that sample mean has manageable number of sample size, like 1,000 or 2,000, 2,500, kind of like that. Population mean, some gazillion, and nearly impossible to calculate. So population mean exists, and you can write like this in theory, but in reality, you don't really want to calculate it. Okay, so much for mean. Let's go to the next topic, and that's median. Now, the median concept may be a little bit new to a lot of students. So let's slow down. Mean, I'm pretty sure everybody must have seen it already multiple times for many years, but this may be a bit new. Basically, the median is the middle number. Let's begin with the same data set as before, this one. Okay, this one. And then sort that data set. And then that's what we have down here, 33 to 94. Now, sorting is done. So let's go to the next step. We're going to find out the middle number. There are 23 numbers here, so there's one middle number there. How do we find it? Typically, we do this. Knock off the smallest number, and then knock off the largest number, and then the smallest, and the largest, and then gradually we can merge in. But this time, let's take 3 at a time. Smallest 3, largest 3, and then let's slow down. Smallest 2 out, largest 2 out. Now this one out, and that one out. The middle number, in this case 77. That is the median. Now what if we have even number of items like this? In that case, knock off the smallest, largest, and then cross out the smallest and the largest, and what do we have left? We have 2 numbers left. So out of these 2 numbers, take the middle, the average of the 2. That is the median. So take the average of these 2, add up and divide by 2, and that'll turn out to be 3.807. That's going to go right in the middle. That's how you handle median if you have even number of items. You're going to get 2 numbers left, take the average of the 2. If you have odd number of items, and knock off, in the end you're going to get the middle number. That is the median. So in a sense, both mean and median measure the central tendency, what's in the middle. However, they behave a little bit differently. Let's consider this kind of hypothetical situation. Okay, here, so mean of this data set. Okay, we got that. Okay, let's suppose somebody makes a typo, and then instead of writing this as 86, 2 more extra 0, and then write it as 8,600. Let's suppose, yeah, okay, all right. And let's suppose nobody caught it. and just calculate the median and mean, as you can see, mean is affected. Because I'm adding up everything and divide by total 23, so this addition of 8,600 is certainly playing a role. So the mean of this data is 445, approximately speaking, while no number here, except for this outlier, exceeds 100, so this is ridiculous. But if you go to median, whether I made this typo or not, median stays the same. Well, that's because it's going to be knocked off anyway. You see? How do you get the middle number? Knock off, knock off, knock off, so it's going out anyway. So what conclusion am I drawing here? If you expect a data set with some outlier, then median may work better than mean. For example, if you go to city data and find some neighborhood and try to find some income distribution there, then you can always get median income, not mean income. That's because if there's somebody extremely rich, for example, is screwing up all those data computation, then in that case, that mean will not do any kind of justice to the distribution of the rest of the people. So due to possible outliers, we usually use median. So when you go over to city data or any other kind of data set, then you'll typically see median income of a certain neighborhood, median house price of a certain neighborhood, things like those. Usually median, not mean. That's because the outlier business. Okay, that is not the only business, but that's one explanation. So in short, median is very, very useful concept, easy to calculate. You can do this without calculator even, with about 20 or about 25 data. Yet, it's even more effective than mean in a lot of circumstances, actually. Not every time, but in a lot of situations. So that's really important. And let's go to the next important topic, quartiles. Median was the middle number, right in the middle, 1/2 or 50% point. Quartiles are half of half, basically 25% and 75%. Let's look at this data set, the same data set, sorted data set, and then 33 to 94, and this is the median, 77, highlighted in red. Now exclude this median and take the lower half and take this lower half of this data and take the median from there. So from here, take the smallest, largest, knock off, knock off, knock off, and in the end, what do you get? You get the middle number here, and that is the first quartile. So this is lower half, and then half of lower half. So it's 1/4. Now you do the same thing to upper half. Exclude the median, take the upper half, and do the same thing. Knock off, knock off, knock off. In the end, you're going to get the middle number. If you get two numbers there, then you can always take the average of the two. In the end, that's the median. So this is the first quartile, and that's the third quartile. And this one, median, is actually the second quartile. 2/4 is 1/2. So this is in 1/4 position. This is 2/4 or 1/2 position. This is in 3/4 position. So those are the quartiles. And here's something called 5-number summary. Of a data, minimum, and then first quartile, median, and third quartile, maximum. These 5 numbers. Basically from here, we have this 33, That's the smallest, minimum. And then first quartile is 69. And then second quartile or median is 77. Third quartile is 82. And this is the maximum. So these 5 numbers express the data set with reasonable accuracy. In this particular case, we have 33, 69, 77, 82, and finally 94. That's going to be the 5-number summary of this data set. Minimum and maximum are really easy. Median is important, the most important of the bunch. And how do you find it? Knock off lowest, highest, lowest, highest, lowest, highest, and so on. In the end, you get the middle number. If there are 2 numbers left, take the average of the 2. Now, quartiles are hardest. Take the lower half and you exclude the median. And then we do the same thing. Knock off, knock off, knock off, knock off. And what's left is the first quartile. If you have 2 numbers left, then take the average of the 2. Same goes for upper half, and that's going to give me Q3, the third quartile. One more exercise. Okay, let's go ahead. One more exercise. Let's consider this data set. We have only 6 numbers here. So, how do you find out the median? Knock off, smallest, largest, and we have these 2 numbers. And take the average of the 2, and that's going to be the number right in the middle, 3.807, I think. Yeah, 3.807, that's a median. That's right here. That's not part of this data set. So lower half will be these 3 numbers. Make sense? Median is right in the middle here, where my mouse is running. Lower half is these 3. So median of the lower half, that's 3.492, and that is your first quartile. These 3 numbers are upper half. And median of that, 4.032, and that is your third quartile. And as you can see here, first quartile, median, and third quartile, they're here. First quartile, and then the second quartile, so 2/4, which is 1/2, so that's a median, and 3/4, so that's third quartile. So we went through quartiles, and also we went through the concept of the 5-number summary. Here, we have 6 numbers here, so getting 5-number summary is kind of overkilling. It doesn't make much sense, but if you have something like this, about 23 data, then using 5-number summary to express this data, that makes a lot of sense. We went through median, the most important, and then quartiles, not as important, but by themselves they are important, and then they can be often tricky. Minimum and maximum, of course, they're easy. Now, do we have enough time to talk about alternative ways to calculate the quartiles? Our textbook way is to exclude this median and then take the lower half like this. But sometimes you include it. Sometimes you include it. And if you calculate median like those, then what's left is going to be, these 2 numbers left. And then these 2 numbers left. So you're going to get different numbers. So quartiles including the medians will generate something different. We're going to come back and discuss this in section 3 as a matter of fact, because MS Excel has both computation. Our textbook's computation excludes the median. So that's the default. We're going to talk about other cases in section 3.